The nice thing about having this sort of problem today is that it's similar to yesterday. We just have to add in that shading component. Another thing we need to remember before we get started, if it is less than or equal to or greater than or equal to, I should have what type of curve? Solid or dotted? Solid. So this would be a solid curve. Remember, these aren't going to be lines anymore. If I had less than or greater than, solid or dotted curve? Dotted. So that's something to remember. And then also remembering that we have to find a test point and we have to shade. So just a couple reminders before we get started that those are some bonus things that we have to do with this problem that we weren't doing yesterday. Okay, so let's think back to some of those same ideas we were talking about while we went over homework. So remember, the boundary is what would make it 0 under the root, because I can't go into negative land. Negative land would be imaginary numbers. That's a whole different graph, okay? What would make what's under the root 0? -5. And again, you can set it equal to 0 and solve it if it's not one that's easy to just like pick out and say, oh, it's -5. All right, -5 plus 5 is 0. Square root of 0 is 0 times 2 is 0. So many zeros. Okay. Then I got to go up from there. I can't go down because going down will get me into negative land and imaginaries. I'm going to pick -4. So this is one that I won't give up on and get decimals like I did on the homework. Do you see how if I do -4 plus 5, that'll give me 1? And that's a nice one, right? What do we know the square root of 1 is? Times 2 is 2. And then, let's see. I like 4 underneath there, right? Under the root. What would I need to plug in to get a 4 under here? -1. If I do -1 plus 5, I'll get 4. And what do we know the square root of 4 is? 2 times the 2 out front is 4. Again, if you don't want to do this in your head, could you use Desmos? Yes. Okay, so I have a point at -5, comma 0. 1, 2, 3, 4, 5. I have a point at -4, positive 2. I have a point at -1, positive 1, 2, 3, 4. Solid or dotted curve for this one? Solid. So up and over. Now, I'm going to draw in some boundaries with my pencil real quick. I'm going to shade, but there's nothing that I'm going to ever shade that is to the left of that point. Because does my graph even exist over here? No. So this region is off limits. Like this isn't, there's going to be no shading here. So you could do that kind of like I did and X it out for yourself first to make sure you don't forget. All right, now I'm going to pick a test point. Do you remember my favorite test point? 0, 0. So I'm going to pick 0, 0. Remember, the only time you can't pick it is if it were in this area or if it were on the curve. Those are our only 2 times it'd be a no-no. All right, let's plug it in. So I'm going to plug in 0 for y, and I'm going to plug in 0 for x, and I'm going to see if it gives me a true or a false statement. So I get 0 is less than or equal to 2 times the square root of 5. So is 2 times the square root of 5 going to be less than or bigger than 0? It has to be, right? So because it's not going to be negative. So this is going to give me a true statement. For giggles, let's just figure out what the number is. So this is going to give me 2 square roots of 5, which is 4.47-ish. So if I type this in my calculator, it's going to spit out this. So true statement, yes? 0 is smaller than that 4.47 number? Okay. Remember, if it's a true statement, then you're going to shade where your test point lived. If it's a false statement, then you would shade the opposite. Do you see how that boundary line is helping me right now because I'm not getting wild and shading across it? So that's why I kind of drew that in there. So again, your boundary will always be wherever your first point is, the vertical line that would go up and down through it. How's that one, okay? Yes, no? Okay. All right, flip when you're ready. We're going to graph some cubic graphs. And the nice thing about these is nothing is off limits. Nothing, nada.
I thought you were about to say the nice thing about these is nothing.
The nice thing about these is nothing. Yeah, no, that'd be a bummer of a way to start off, wouldn't it? All right. So let's look at the graph. So these graphs, cubic graphs, are going to look like this. So they kind of look like a little snake. They look like a letter S. They also remind me of, so it's a cube root. It kind of reminds me of the cube graph, right? But then it's just on its side. So that's another way to think about it. So the domain, do you see how it's going to span out and hit all real numbers? So that's nice. We don't have to think about anything there where it's restricted. Do you see how it's going up and down? It's going to eventually expand out and hit all real numbers up and down as well.
Will that always be the case?
Yes. Yes. Always. Because even if I shifted it up or I shifted it down, it's still, like, if it has until infinity to do its thing, it's going to hit everything. So yeah, these should be all real numbers all the time. And not even just for cube roots. These are going to be true for anything where you have an odd root. All the graphs will look a little different. So if you had like a fifth root, it's going to look a little different than a cubed root. But all of your odd roots are going to have a lot of the same stuff hold true. All right.
What about even roots?
The even roots is what we were doing yesterday. Yeah, so everything that's even will follow suit with yesterday. Everything that's odd goes together. Okay, end behavior. So again, for the most part, unless we have a reflection, our graph looks like this. So as we go to the right, so as x approaches positive infinity, what's my y doing? It's going up, so it's also going to positive infinity. As I go to the left, what's my graph doing? Going down, so it's going to negative infinity. What do we think about symmetry? Yeah, it has symmetry. It has what we call point symmetry. And the point symmetry is here at the center. So if we were to take this and rotate it, it would land back on top of itself. Now, if we don't shift our graph anywhere, our x and y intercepts should both be at 0. So we can say both at 0 unless there are shifts. So if you shift it left or right, that's going to change where the intercept is. But otherwise, if you don't do any shifting left or right, it's going to hit right here every single time. So it's going to hit at the origin. So the origin is both, right? Okay. Then, kind of like yesterday, identical to yesterday. Do you remember seeing some of these letters? So anything out front is going to be a vertical stretch or compression. Anything underneath added or subtracted to x is going to be a shift left or right. Anything added or subtracted out back is going to be a shift up or down. And then the only other thing that we came across sometimes was a negative out front. So remember that a negative out front, so out front of everything, will reflect over the x-axis because it impacts what y is equal to. So that's the only thing that's not represented. So meaning if I put a negative out there. So let's look at an example. So our first one is just like yesterday where we're just looking at it and we're saying what happened. So our parent function is the cubed root of x. There's no cube root there, so put a cube root in for me. So that's our parent function. Remember, parent functions are the most simplistic, toned down version of the function. All right, so we've got, I see 3 things that have happened. Who can tell me one of them? Go ahead, Sam. Vertical what? Yes. Vertical compression by 1/2. So remember, it's a stretch if it's a number bigger than 1. It's a compression if it lives in between 0 and 1. And remember, our negatives are reflections. They don't have anything to do with stretch or compression. Go ahead, Andrew.
Right 4.
Right 4. I love that. So we're going to have a shift to the right by 4. So make sure you also write shift in there. Or if you want to be classier than me, you can write translation. I'm going to write shift right 4. Okay, we got one more shift. What is it? Go ahead. Up 5. So shift up 5. So some of the questions on the homework will be that easy, just asking you what transformations are going on. Yeah?
Is there anything with the little 3?
What do you mean the little 3?
Because it's not in the third.
It should have been there.
Oh,
Yeah, I wrote it in. It should have been there. It was not. That's a typo versus like, oh, it changed.
Okay.
Yeah. Good question. Okay. So let's do a graph. And again, I'm only going to ask you to graph and then do domain and range. Let's take a moment. I'll pause the video while you do that. Okay. So how do you do this on Desmos? Well, I'm not even going to pretend that I knew. You guys helped me figure it out because we had to go down here to this function button, right? So once you pull up the keyboard, then we need the function button. It's like deep within the program here. Scroll all the way down to the bottom. And do you see how we have an nth root hanging out? Click on that. And then I'm here. So we need, for number 4, we need a 3rd root. So I'm going to put a 3 up there for my index number. I'm going to arrow to the right because then it's going to pop me down under my root. I'm going to type in X. I'm going to hit shift equal sign so I get my plus. And then I'm going to type 4. So remember, that should shift you left 4. We were just talking about the transformations. Do you see how it took it from the origin and shifted it left? Okay, so that's kind of nice that we can see that transformation happening. Now, do you see how I'm still living under the root? I want my -1 not under the root. So I'm going to hit the arrow key to the right so I get out from under the root, and then I'm going to hit -1, and that should then drop me down 1. And now I can find whatever points I would like to graph. So I'm going to pick a couple, and then I'm going to go back over to my sheet and show it to you. So here's my XY table. Hi.
Hello.
What- Can you come back in about 7 minutes?
Yep.
I love that. Thank you. All right. So -3, 0 is one of the points I want to graph. I'm also going to graph, oh, that's kind of ugly, but I mean, sure, why not? I'm going to graph 0 and 0.59. And then I'm going to graph something down here so I can see the other part of the S. So I'm going to graph this one. I'm going to go -6.
There's -5 too.
Oh, well, that's much better. You can graph whatever you want. I mean, there are infinitely many points. So truly, like, if we played the game of graph the same point I graphed, like, that's not a thing. That would be bad. Because there are infinitely many out there. So you pick what you want to pick. But again, you kind of want that center point. Remember, we talked about the symmetry? And then we want a point that kind of shows us both parts of that S shape.
Do they have to be like in an order?
Yeah, I didn't put them in a nice order. Yeah, no, I didn't. I'm okay if they're not. So my first point is over 0, and it's up at 0.59. So about here-ish. -3, 0. And then -6, so -3, 4, 5, 6. And then -2 and a little bit more. So my graph does one of these. So again, definitely 3 points for this one as well. And do I even really need to think about the domain and range? No, because it's all real numbers for both. Negative infinity to positive infinity. Negative infinity to positive infinity. Okay, so that's nice for that part at least. Okay, let's try the next one. Let's graph it. All right, so I'm gonna see if it'll let me click out front. Oh, it did. Nice. Okay, so I'm gonna type my -2 in. So do you see how the next one has got the -2?
Wait, are we doing the shading?
Nope, no shading for this one because there's no inequality. These are just graphing.
Oh.
Yep, no shading. Good question. Yep, we were shading earlier. This is not a shade one. This is just an equals. Okay, -2 out front, cubed root, and then I can get rid of a lot of this because it's just the cubed root of x, right?
Yeah.
Okay. So do we get something that looks like this? Okay. So 0, 0 is a point. So I definitely want to graph 0, 0. Like that's one for sure I want. Okay. So then let me pick something over here. Again, you can pick whatever you want. That one looks like it could be nice. Is it?
You can do.
Oh.
1, 2.
-1 what? -1, 2. I love that.
You can also do
And then
1,
+1, 2. Yeah. So -1, +2, which means 1, -2 is also going to be there. Okay, love that. And again, if you can't find a nice point and you use one that's not so great, that's okay. Just be careful when you round. Make sure you round correctly. So I have a point at -1, +2, and +1, -2. And again, we know it kind of does one of these numbers. Okay, so I reflected. So my end behavior would be different if I had to fill that out. But are my domain and range still all reals? Yes. So my domain is still all reals. My range is still all reals. Good? Okay.
Wait, what's the rest of it?
Yeah.
I have a question.
Yeah, go ahead.
I don't really know if it like relates to this right now, but like, if you were just given like those points and you weren't looking at like the graph on the
Yeah.
points, how would you know if it was like an S or a straight line?
You need to look at the graph on there to get the curvature, or you need to graph way more points. That would be the other kind of solution to that problem is graph way more points. But I don't think a lot of you are going to like that answer. So the answer you're going to like from me is, like I said, look at Desmos and look at like where it ends up. Okay, so the homework for tonight is 14 to 17. So look at those first 4. Those are all shading. And then you're going to do 20 to 23, and those are like the second ones we did. Those are no shading. And you have to state domain and range.
What page is it?
Page 330. So we are